Okay, so let's look at this last example. Again, you can see that it looks more complicated, but we're going to look at one section at a time. So let's look at the first section, okay, before we multiply it by the second bracket. Okay, so as I said, one suggestion I suggested earlier was do anything with power. So I have a power of 2 here. So it's going to actually be multiplied by 2. 2 needs to come into the 3 and to the z. So that's the first thing I'm going to do. So 2 to the x to the 4th y cubed all over. And I just want to make this a little bit thinner than what it is. There we go. So that's going to be 3 squared z to the negative 6. Okay. Now the next one, I have a power on the top. So it's going to be 3 squared z to the 7 times 2, which is 14, all over 2xy to the 6th. Now again, it's a little bit easier to do. And that's maybe a little bit too late. Okay, so what I'm going to do is I can see that certain things go together. We can simplify the top, but nothing really counts with the top there. You can see that here I have a 3 squared, and I'm dividing it over here by a 3 squared. So actually the 3's are gone. Also, so we'll just actually stroke them out. You can see that down here I have a 2, and I'm dividing also the 2 divided by 2, so that's gone. So those equal 1 in both cases. On the top of the first, I have an x to the 4th. And on the bottom of this one, I have x to the power of 1. So that means I would have to subtract. My y on the first one is y cubed. And on the bottom here, I have y to the 6. So I need to subtract 6 because I'm dividing by it. Then I can see that I have z to the 14 on this one. And I'm going to subtract a negative 6. Okay. So if I look at this, so I have x cubed, y to the negative 3, and z to the 20th. Now one of those has a negative exponent, which is the y, so the y is going to go on the denominator of the question, of the answer. All right. Now the other thing that you can do with power laws has to do with probability, and so we're going to take a really quick look at this. So exponents and probability. Probability equals the number of desired outcomes, so what you want, and divided by the total number of any outcome happening. So for instance, if I have a multiple choice question, has 5 choices for answers. If you guess at the answer without reading it, what are your chances of getting it correct? Well, let's take a look at this. So if I look at the probability of this one, there is only one right answer. So that's the desired outcome. I want the correct answer. But how many choices are there in total? There are 5 choices. So I have a 1/5 of a chance of getting the correct answer, or 20%. So now, if you guess at 5 questions, what is your probability of getting them all correct? Okay, so I'm doing this 1/5 5 times. So the probability here would be 1/5 to the power of 5 because we have 5 multiple choice questions. Okay, and so that brings this in. 1 to the power of 5 is still 1, and 5 to the power of 5 is quite a large answer. So you really are setting yourself back at not getting the correct answer, because 5 to the power of 4 is 625, and then by another 5. So you really wouldn't have a very good mark if you guessed everything. Okay, homework. There it is. Have fun.